It happened in Iceland on Friday, March 19, 2021 at 8:45 p.m. About 20 miles southwest of the capital. Molten rock suddenly burst through the surface from below. Bright lava fountains then lit up the night sky. A volcano in this valley finally woke up after almost 800 years of sleeping soundly. We divide volcanoes into three categories: active, dormant, or extinct. Around 1,900 of them around the globe are considered active. That means they've erupted in the recent past and will likely do it again in the possible near future. Dormant volcanoes haven't popped off for a long time, but they still may in the future. You could say they're sort of sleeping. As for extinct ones, those guys haven't done anything in more than 1 million years. The eruption in Iceland wasn't super explosive, and this all happened 6 miles from the nearest town, so everyone was perfectly safe. Many even came to see it up close, while other brave visitors tried to fry eggs and bacon on the lava. Just be careful not to burn your breakfast black. Lava can be over 2,000 degrees Fahrenheit. It burns everything in its path. Yet it also produces some of the most fertile land for agriculture. This eruption gave a relatively small amount of lava at first, but it's been spreading across the valley in different directions, forming a sort of shield that's constantly growing. You can never really predict how fast a lava flow will be until you see it. It all depends on how thick it is and how steep the mountain slope. Lava can ooze slowly at about 20 feet a minute, a fraction of the average person's walking speed. Or it can flow as fast as 30 miles per hour, which even the fastest person on Earth can't outrun. But the lava isn't even the most dangerous thing about volcanoes. That would be the toxic gases spewing from the eruption. And those spread faster and further than the lava flow. Luckily, in Iceland's case, the wind has been blowing these gases away from residential areas. Scientists weren't surprised this volcano erupted. They knew it was coming. Increasingly stronger earthquakes had been shaking this area for the past 15 months. There were 50,000 earthquakes within just the 3 weeks leading up to the eruption. That's 100 per hour. The volcano has been active since March, and geologists say this could last for weeks, months, years, or even decades of constant eruptions in the area. Mount Shasta is in the top 5 most dangerous volcanoes in the U.S., so geologists are keeping a close eye on it. The last eruption was in 1250. I wasn't around then, but this volcano erupts every 600 to 800 years. Which means tick-tock, we're due any day now. About an hour from Portland, Oregon, there's an active volcano that last erupted in the 19th century. Next time it goes off, scientists think it'll produce larger amounts of ash and dust. This could cause an electrical blackout and make water unsafe to drink in the area. But the experts pay close attention to Mount Hood. They'll be able to give plenty of warning so people can react in time. Kilauea is one of the most active volcanoes in the world. It's been erupting almost constantly since 1983, making it also one of the longest eruptions known on Earth. It's the youngest land volcano in Hawaii. Volcanoes can take thousands of years to form, but others can pop up practically overnight. A volcano in Mexico just erupted in an open field in 1943 and started growing from there. Within a year, it was almost 1,500 feet tall. When the eruptions finally stopped 9 years later, the mount had reached a height of over 9,200 feet. Mount Fuji is an iconic symbol of Japan. The last time it erupted was in 1707, and it sent a shower of burning rocks as far as 60 miles away. If a similar eruption happened today, Tokyo would be within that vicinity. Mount Fuji is right on the Ring of Fire, that horseshoe-shaped region in the Pacific Ocean full of active volcanoes and earthquakes. From one end to the other, it's almost 25,000 miles long. It could wrap all the way around the Earth's equator. In January 2020, Taal volcano in the Philippines started spewing lava, sending huge plumes of ash half a mile up into the sky. The eruption even triggered a rare phenomenon, a dirty thunderstorm. That's when the smoke cloud above a volcano produces its own lightning. The chance of volcanic tsunamis was also high. Those are usually caused by tectonic movements that occur because of volcanic activity. Taal has erupted more than 30 times in the last 450 years. This volcano in Ecuador last erupted in 2016. Scientists think it might be showing some early warning signs of magma on the move. This is an active stratovolcano, a specific cone-shaped type with steep sides. They form from sticky lava that doesn't flow that easily. That lava goes around the vent, cooling and piling on itself to form these steep walls. These types are more likely to produce explosive eruptions like the ones we see in movies. Ruapehu is the oldest national park in New Zealand, a volcanic wonderland where you can closely see all those steaming craters, magnificent lakes, and unusual rock formations. It last erupted in 2007 and has had 10 eruptions since the mid-19th century. But eruptions, lava flows, and toxic gases aren't the only danger coming from volcanoes. There's also a thing called lahar, a kind of volcanic mudflow of debris. In between eruptions, snow melts and a lake forms in the caldera. If the last eruption brought mud, ash, and rocks in the lake, it becomes dangerously full. In that case, only a temporary dam holds it back. Indonesia has the biggest number of active volcanoes in the world, including one called Anak Krakatoa. It means child of Krakatoa, and its famous parent isn't far away. A huge tsunami in 2018 partially woke Junior, a scary thought since Senior had one of the most powerful eruptions ever seen on this planet in 1883. Krakatoa's boom was the loudest sound ever heard. People over 2,000 miles away could hear the explosion. The sound wave circled the globe 7 times, and scientists say it's hard to predict this volcano's eruption patterns. Mount Rainier in Vanuatu is one of just a few volcanoes in the world where you can see a lava lake. Tourists even go there to peer over the edge and get a look at the burning, bubbling lake below. Well, except for when the volcanic activity goes to levels 3 and 4 out of 5. That means there are more intense earthquakes, volcanic tremors, or steam, gas, or ash ejections. Then this place is off limits because, duh. This volcano in the DR Congo has the most active and largest lake volcano in the world. And all that lava is unusually fluid, meaning it travels faster and further than the stuff coming out of most volcanoes. It's certainly not amongst the tallest ones, but Ethiopia's Erta Ale is unique in that it has a lava lake almost constantly, which is pretty rare. The locals call it a smoking mountain because its lava lake often causes eruptions. This volcano is near the Danakil Depression, one of the hottest places on our planet. Merupi has been erupting on a regular basis since the mid-16th century. This volcano helps scientists do crucial research on how eruptions work and how they can warn people in time. After it was dormant for a while, this volcano in central Mexico sprang back to life in 1994. Ever since then, it's been producing huge mud flows and strong explosions in unpredictable intervals. In the past, enormous eruptions coming from this giant buried entire cities in pyramids. Imagine staying in a hotel and waking up to the magnificent view of a massive volcano covered in glowing rivers of lava and clouds of ash. When it lets off heat, visitors to this area in Guatemala take a chance to roast some marshmallows there. One of the most active volcanoes on Earth is on a small island north of Sicily. Stromboli has regular explosions, together with glowing lava coming from vents inside the crater. Not too far away is Etna, Europe's most active volcano and one of the biggest continental ones in the world. By the way, Earth definitely isn't the only planet with volcanoes. The largest one in our solar system is on Mars. It would cover the entire state of Arizona, and it rises nearly 3 times higher than Mount Everest. Ooh, don't look down. When we think of active volcanoes, one region comes to mind: the Ring of Fire in the Pacific Ocean. 3/4 of Earth's volcanoes sit within this belt. Compare the area to Australia, which doesn't have any volcanic activity. The old continent of Europe is also calm, or at least we like to think so. Can you guess what the most active volcano in Europe is? If you thought of Mount Etna on the island of Sicily in Italy, you were right. The volcano has erupted about 200 times and has been far from sleeping in recent decades. The last time this happened was in August 2023. The highest mountain in the Mediterranean is 500 million years old. But in Iceland, there is a much younger volcano. It sprang into action on the 10th of July 2023. In the afternoon, 3 fissures appeared in the ground on a peninsula in the southwest of the island. This was at a base of a small mountain peak. Its name means Little Ram in the local language. The volcano spewed molten lava high into the air. There were also gas plumes in the area. But the scientific community wasn't surprised by the event. They already knew about the volcanic area that stretches between the cities of Reykjavik and Keflavik. Its name is hard to pronounce. Hey, I want to buy a vowel. It had already erupted during the previous 2 summers. This activity came after 8 centuries of dormancy. In the days leading up to the latest eruption, seismologists, the scientists who study earthquakes, recorded over 12,000 tremors. When the ground opened up in July, the fissures were over 1.5 miles long. The following morning, 2 of them closed. All the lava was now coming out of the last fissure. It grew into an elongated cone, the simplest shape of volcano we are all familiar with. The lava soon filled a large crater. It grew almost 100 feet tall during the first week, and it is still growing. On the night when the eruption started, lava spread out in all directions. Its cinders set ablaze the dry moss in the vicinity. Local authorities closed off the surrounding area. There were toxic gases from the volcanoes and smoke from the burning moss. Firefighters flocked to the area. After a week, they proclaimed the area safe. Visitors soon came to witness the birth of Europe's youngest volcano. This form of tourism is quite developed in Iceland. People come from all over the world to watch active volcanoes. The land of fire and ice is home to more than 130 volcanoes. Some 30 of them are active. Now, I know what you're thinking right now. Is volcano tourism safe? In Iceland, it is. The country's authorities research and constantly monitor all of the hotspots. The island is dotted with several dozen seismic stations. These help researchers accurately predict future eruptions, and emergency services are accustomed to these sorts of events. They can quickly cordon off danger zones. This is what happened in 2010. A volcano in the south of the island, the name of which everyone struggled to pronounce, erupted. It spewed out a plume of steam and ash that was 7 miles high. This wasn't a fun time to be an air traveler. Winds carried the enormous plume southeast toward northern Europe. Many countries closed their airspace for several days for safety reasons. The volcano erupted in March, but the Earth was shaking from January the same year, so seismologists knew that an eruption was approaching. When it comes to the continent's youngest volcano, the tourist infrastructure is already there. Visitors can leave their cars at a designated parking lot. Then they go on a 5-hour-long trek. This leads to a viewing deck. Tourists are so close to the epicenter that they can feel the heat haze from the crater. The sight is the most impressive at nighttime. Safety is never a concern. Scientists regularly chart out hazard maps that outline the borders of lava fields. This way, visitors who stick by the rules are never in harm's way. More than a week after the eruption started, a section of the crater collapsed. Lava flowed downhill west of the volcano. This majestic smoldering hot river is slow-moving lava. Scientists categorize it as an AA type. The term is Hawaiian. It describes basaltic lava that has a rough and brittle surface. The flow is composed of broken lava blocks that are called clinkers. They fall off as the substance flows. This reveals red-hot areas. The cooler sections of lava are gray and black in color. When it moves forward, it produces a distinctive sound like shattering glass. Nearly a month after the eruption of the new volcano, we got aerial footage of an interesting phenomenon. A tornado formed directly over the lava flow. This occurs due to the high temperatures in the area. When the conditions are right, a column of heated air can easily turn into a mini tornado. Scientists observed a similar event happen during the 2018 eruption of Mount Kilauea in Hawaii. The lava fields of Europe's second-largest island tell the story of the creation of Iceland. It sits above the place where the North American and Eurasian plates meet each other. Tectonic plates are huge, rocky chunks of Earth's most outer layer. There are roughly 20 of them. They rest on a partially molten layer of rock. All the lava we see on the surface starts its journey here. You could say that these plates float on molten rock. Their boundaries are unstable, so when two plates grind past each other, they release tremendous amounts of energy. The formation of volcanoes is one result. These are places where the molten rock travels upward to the surface. Iceland began to form some 60 million years ago. The tectonic plates under the ocean drifted apart. Enough lava piled up on the surface to create solid ground. This ancient rock is under the waves today. As new lava reaches the surface and cools down, it pushes the old rock away from the center of the island. That's why the oldest parts of Iceland aren't 60 but only 16 million years old. The country's active lava fields are young in geological terms. Some of them are under 1,000 years old. Scientists consider the island a hot spot for volcanoes, pun intended. Nearly a third of the basaltic lava that reaches the Earth's surface in recorded history came from Icelandic eruptions. Fissure swarms, like the ones before the 2023 eruption, cover 30% of the Nordic country. For this reason, only a quarter of the island is inhabited. Norse Vikings were the first people to settle in Iceland at the beginning of the 10th century. Nature threw them a loud welcoming party. Just a few years after their arrival, they witnessed one of the greatest volcanic eruptions in history. Vikings came from a region without volcanoes, so they had no clue as to what was going on. Today, Icelanders are used to such events. This is good because their homeland is entering a new era of volcanic activity. Volcanologists suspect that recent events are an introduction to decades of more frequent eruptions. The peninsula that is home to Earth's youngest volcano is just 17 miles southwest of Iceland's capital city. It's been dormant for a long time. Present-day eruptions there are a reminder that the natural processes that created Iceland are still ongoing. Recently, scientists discovered that there's a historical link between volcanic eruptions in the north of Europe and glaciers. Our planet went through at least 5 major ice ages. These were exceptionally lengthy periods when the average temperature on Earth dropped. The result was the expansion of ice sheets across northern Europe and North America. The last ice age ended some 10,000 years ago. Researchers are still trying to fully understand how these glacial periods affected volcanic activity. They suspect that the sheer weight of all that ice disrupts the flow of magma underground. When glaciers retreat, the pressure is lifted. This makes it easier for lava to flow upward to the surface where it bursts. The ground shakes beneath you. The pictures rattle on the walls. You hear a rumble off in the distance. Then, boom, a deafening explosion. The shockwave blasts through the windows and sets off car alarms. You duck under the dining table for cover, but then you remember you live not far from a supervolcano in the middle of a tropical jungle. So, staying in one place isn't a good idea. The shaking finally halts. You take this chance to peek outside and see a giant cloud of smoke covering the sky. It's lunchtime, but you wouldn't know it. The sun is completely veiled and darkness falls. The power's out in the whole city. In this darkness, you see red molten lava shooting from the sky and spilling on the rim. You run outside along with dozens of your neighbors. Your priority right now, find safe shelter and fast. You think about taking the car, but with everyone running on the road, that's a no-go. So you run on foot where the crowd is going. Supervolcanoes are in a league of their own when it comes to natural disasters. Surprisingly, it's not all about size or height. A volcano is dubbed super if it erupts more than 240 cubic miles of magma. That's more than enough to overfill Lake Erie. It must also have a history of erupting and a magnitude of 8 on the Volcanic Explosivity Index. The largest active volcano on Earth is Hawaii's Mauna Loa. It's so big it would cover the entire state of Rhode Island plus some. And next time you see a commercial plane flying high in the sky, remember that 30,000-some-foot altitude is about as tall as Mauna Loa is from base to summit. It's technically taller than Everest when you measure it like that, yet it's not considered a supervolcano. So you're running along the dark road not knowing and barely seeing where to go. Then, all of a sudden, a massive flaming boulder smashes through the bridge in front of you. You and everyone else are now stranded on the side of the volcano as it's getting more chaotic each second. Most of the crowd disperses, finding their own ways to safety. You remember there's a way to the other side not many people know about, but you'll have to cross a raging river through the dense jungle. You calm what's left of the crowd, and everyone follows you to your secret getaway. You finally get out of the city limits and head into the jungle. With the sky already dark, the tall trees and thick leaves make it almost pitch black. Everyone gets out their phone flashlights to navigate through the dark path. You all need to stick together and make sure nobody gets lost. Suddenly, fiery rocks strike the trees not far from you. Everyone jolts and tries to rush ahead, but nowhere is safe when it's raining scalding fire all around. You and your group have to pick up the pace or else. Imagine a typical avalanche or mudslide, very dangerous situations on their own. Now, imagine an avalanche of lava rocks and lava sliding down a mountain instead of mud. That's what's making its way towards you right now. More and more people catch up with your group and bring news that the entire neighborhood is submerged in lava. It's traveling quicker than you thought. You can never really predict how fast a lava flow will be until you see it. It all depends on how thick it is and how steep the mountain slope. Lava can move slowly at about 20 feet a minute, a fraction of the average person's walking speed. Or it can flow as fast as 30 miles per hour, which even the fastest person on Earth can't outrun. But the lava isn't even the most dangerous problem. If you didn't have protection, the gases spewing from the eruption would fill your lungs, and those spread faster and further than the lava flow. Your eyes and throat would be itchy. You'd get a headache, dizziness, increased heart rate, difficulty breathing. The worst would be passing out from the lack of oxygen. Luckily, everyone managed to grab their gas masks before leaving their homes. You're now entering the treacherous terrain of the jungle and the danger zone. Everyone's phone batteries are giving out one by one, so your vision is even more limited. The terrain is tougher and you can't hear any sounds from the river. At this point, you're not even sure if you're going the right way. But your instincts tell you the deeper you go, the safer you'll be. The path is muddy, and the vines are hindering everyone's movements. That's when you hear something big running through the jungle. It's coming up on you fast. You can't see a thing until it's right up on you. A bear! And there goes a rhino. Wild cats, domestic cats, dogs, different creatures of all sizes and species. They all come running through the jungle right past you. You and your fellow humans aren't the only ones fleeing from the eruption. The rumbling is still going on. Before you know it, a shower of fire rock strikes right behind you and ignites parts of the jungle. There's no going back. Everyone picks up and runs for it. You hear thunder in the distance. A flash of lightning lights up the dark sky. You think, finally, some rain to wash away this fiery nightmare. But that's not a regular storm brewing. These giant smoke clouds can mimic a thunderstorm under similar conditions. Your luck finally pays off. You hear the river straight ahead. You reach the bank and have to hop on some stones to get to the other side. You almost slip when someone from the group catches you just in time. Whew, that was too close. Not far down the river is a large waterfall leading straight to a shallow lake with sharp rocks at the bottom. The ash from the lava falls like snow, covering most of the trees and landing on the river. Ash is one of the most dangerous things about volcanic eruptions. You're soaked to the bone, but it's a lot better than ash and smoke. And then the rest of the group follow. The next thing you know, the river starts steaming as lava meets the bank and runs into the water. You try your best to speed things up. The lava can heat this water up to dangerous levels, and there are still people slowly crossing the river on the slippery rocks. Luckily, you manage to get everyone across. Well, almost everyone. You turn around and see someone's leg got caught between two rocks. The lava continues to pour into the river. You can feel the heat of the steam. You rush back to this person and try to pull them out. Their leg won't budge. Someone else from the group comes to help, and you're finally able to pull them out in the nick of time. You and everyone else, now exhausted from your trek, keep going as far as possible. That's when you see the main road that connects you to the broken bridge. There are others on the road that got out safely, and even some cars filling up with survivors and heading fast out of the area. The volcano is still spewing lava, and the entire city is flooded with it. What was once your town now looks like a giant burning lake. Planes and helicopters can't fly because of the smoke and ash, so don't count on an air rescue. You're still at risk even though you're on safer ground, so it's still too early to celebrate. Everyone continues to move away from the city. The further, the better. The ground continues to shake, but this time it's even more intense than before. Supervolcanoes are powerful enough to cause many earthquakes. But it's a good thing you're out in the open, far from the buildings and debris in the city. Now, back to reality. Rest assured that a volcanic eruption of this intensity won't happen for a very long time, as in millions of years. Besides, thanks to warning systems and humanity's preparation for such an event, it's extremely rare for even a regular volcano to do as much damage as it could. So, don't scratch Yellowstone off your travel list just yet.
The latest super eruption of Yellowstone occurred 640,000 years ago, and it was long before Homo sapiens saw the light of day. But we were around during another, no less devastating natural disaster. This super eruption took place on the island of Sumatra around 74,000 years ago. That's when an erupting supervolcano wreaked havoc on huge territories, sending up plumes of debris and ash that spread for thousands of miles and caused temperatures on the planet to plummet. The effects of this super eruption were visible as far away as southern Africa. Experts believe they could have impacted early humans there. By the time the volcano erupted, our ancestors had already been using stone tools and had likely known how to produce yarn. And some specialists even think that the Toba super eruption was so powerful it could push our ancestors to the brink of extinction. They claim that Toba might be the largest volcanic eruption to occur on Earth within the last 2 million years. The eruption disgorged so much pyroclastic rock it would be enough to cover the entire United States to the depth of a one-story house. About a third of that deposit piled up on northern Sumatra, while a lot more ended up beneath the floor of the Indian Ocean. The super eruption left an elliptical crater lake around 60 miles long. The caldera is so large it's hard to feel that you're indeed in a volcano. Pumice deposits from the eruption remain in the canyon walls and go deep below the ground. There aren't many arguments about the amount of pumice and ash involved in this disaster. At the same time, experts aren't sure how much sulfur ended up in the atmosphere. Even some sulfur layers in the polar ice could be potential candidates. But so far, scientists haven't found any connection between them and Toba. But let's get back to the dramatic impact the super eruption had on early humans. It turns out some not only survived but even thrived after this natural catastrophe, at least judging by the artifacts they made during and after the eruption. The disaster might not have posed a serious threat to those of our ancestors who took refuge along the coast. Genetic evidence hints that modern humans descend from a few thousand people that ventured out of Africa around 60,000 years ago. Why just a few thousand? According to some experts, the rest of our ancestors could have been devastated by the Toba eruption. After all, the supervolcano spewed out 1,000 cubic miles of dust and rock in a flash, leaving a scar in the ground that was dozens of miles wide. All that dust and sulfur Toba sent into the atmosphere potentially cooled the surface of our planet, which led to the appearance of glaciers and the lowering of Earth's sea levels. And since Toba might have had an important role in shaping humankind, scientists have been working hard trying to understand precisely how early humans reacted to this disaster. In 2011, several researchers found an enigmatic soil sample in South Africa's Pinnacle Point, an archaeological site overlooking the Indian Ocean. This sample contained some volcanic ash. After examining the layer, they found more than 400,000 artifacts left by early humans. Those ranged from heat-treated stone tools to signs of fire and animal bones. Based on this finding, the team suggested that early humans on the South African coast thrived after the eruption, living in that area for thousands of years and improving their tools. The region might have served as a refuge during and after the Toba eruption. A 2009 study suggested that the eruption could have lowered global temperatures by 14 degrees Fahrenheit. It would have made survival tough elsewhere in Africa. If there had been a volcanic winter, it wouldn't have been as cold along the coastline. On the other hand, newer studies claim that Toba spewed out so much sulfur into the atmosphere that the resulting aerosols could have stuck together, which would have limited their cooling effect in the long term. In other words, right after the eruption, temperatures would have plummeted, but only in some regions. And after 3 years or so, the effects of the eruptions would have calmed down altogether, becoming not dangerous to humans. Well, apparently, more research is needed. Meanwhile, let's figure out if we should watch out for any volcanoes these days. Last year, thousands of small earthquakes shook the ground near Iceland's Svartsengi geothermal power plant. Magma rose to the surface there, and now it has opened wide fractures slicing through the small town of Grindavik. The ground there is still swelling, and an eruption might happen with little notice. But of course, that's not all. Over the planet, 45 other volcanoes keep rumbling. For example, Italy's Vesuvius, that infamous thing that finished the city of Pompeii in 79 CE. Over the last 17,000 years, the volcano has experienced 8 explosive eruptions, followed by powerful pyroclastic flows, dense masses of super hot ash, lava fragments, and gases flowing at high speeds. The volcano's last eruption happened in 1944. Mount Rainier is one of the most dangerous volcanoes in the USA. Its high elevation, chemical composition, and proximity to Washington's Seattle and Tacoma suburbs, and the volcano's ability to produce massive pyroclastic flows make Mount Rainier a threat to consider. The heat from this volcano could potentially melt the ice and snow covering it, leading to rapid downstream flows of debris, mud, and rocks. The Novarupta volcano in Alaska's Katmai National Park and Reserve formed in a 1912 eruption, which was the world's largest in the 20th century. The volcano sent almost 7 cubic miles of ash and debris into the air. It also produced such a powerful ash flow that it created the Valley of 10,000 Smokes. Mount Pinatubo is located in a populated region in the Philippines. It became notorious after a 1991 massive eruption, which was the second largest eruption of the 20th century. More than 700 people lost their lives during that natural disaster. Today, more than 21 million people live within 62 miles of Pinatubo. Mount Agun, a continuously erupting volcano in Indonesia, had its last major eruption in 1963. It was one of the most tragic eruptions in the country's history. It lasted for 11 months, producing ashfall and pyroclastic flows that led to the loss of more than 1,000 lives and serious property damage. People saw ash plumes above the volcano throughout 2018, following the eruption in November 2017. Japan's Mount Fuji hasn't erupted since 1707. That year, a massive earthquake likely set it off. In 2014, experts warned that Fuji could be at risk of another eruption following the 9-magnitude earthquake that shook Japan in 2011. Experts believed the earthquake had raised pressure below Fuji. The eruption in 1707 sent so much ash and debris into the air that all this mass even reached Tokyo. Should Fuji erupt again, it would affect more than 25 million people in the surrounding areas. The eruption of Washington's Mount St. Helens in 1980 was one of the most destructive volcanic events in U.S. history. 57 people, as well as thousands of animals, lost their lives during that natural disaster. The eruption also destroyed around 200 square miles of forest. Experts think that Mount St. Helens' history of massive eruptions means that future catastrophes are bound to happen. The next explosive eruption might send large amounts of ash all over the Pacific Northwest. No wonder the volcano is under close monitoring. One of Indonesia's most active volcanoes, Mount Merapi, has been erupting for centuries. NASA claims that the biggest risk of this volcano is pyroclastic flows, which can spread over vast areas and harm loads of people. For the last time, Merapi erupted in January 2024, sending plumes of smoke into the air. These days, more than 24 million people live in the area surrounding this volcano. It's the 15th of January 2022, 4:47 p.m. local time. It will start any moment. Here, do you feel these jolts? The South Pacific is about to experience one of the most powerful volcanic eruptions ever recorded by modern instruments. The eruption begins at Hanga Tonga Hanga Ha'api, an underwater volcano in the Tongan archipelago. The eruption itself is enormous. Its volcanic explosivity index is at least VEI 5, with the maximum being 8. It's as powerful as such historic catastrophes as Mount St. Helens in 1980 and Mount Vesuvius in 79 CE. The eruption releases a staggering 2.4 cubic miles of volcanic material and sends over 150 million tons of water vapor into the stratosphere. This amount of water vapor would have been enough to fill 58,000 Olympic swimming pools. Additionally, the eruption generates the fastest underwater currents ever recorded and triggers large tsunamis that struck areas as far as Peru, more than 6,200 miles away from the volcano. And it takes at least 4 lives, with even more missing. But the craziest thing is that just before the eruption, 15 minutes ahead of time, there was a kind of warning. But as it often happens, people simply missed them. 2 seismic stations, about 466 miles away from the volcano, which is pretty far for this kind of thing, picked it up. They figured out it was a Rayleigh wave, which is a type of seismic wave that moves along Earth's surface. This wave was caused by a fracture in the ocean floor, where magma and seawater started to interact under a lot of pressure. That's likely what triggered the eruption. The crazy thing is that normally, volcanic seismic signals are pretty small and can only be detected close to the volcano. But this Rayleigh wave traveled way farther than usual and was much stronger. It means there had to be a massive amount of movement going on beneath the surface before the eruption. While people on the ground didn't feel it, those distant sensors picked it up. And this discovery is great for identifying volcanic threats earlier in the future and for improving early warning systems. If scientists can detect these seismic precursors, they could give a heads up before an eruption happens. That would give people time to evacuate and reduce the chances of injuries or property damage, especially for underwater volcanoes like this one, which can also trigger fatal tsunamis. Now, the eruption was big, but its impact was mostly contained. However, this discovery underlines how important seismic data is for predicting and preparing for these disasters. Even though this precursor wasn't used to issue a warning during this eruption, the idea that we could use this kind of information in real time during future eruptions is really promising, especially for underwater eruptions, which apparently might give us more warning time than we thought. Even though we wouldn't have been able to hear that precursor warning signal, there is a sound so loud it could actually finish you. And while such sounds are incredibly rare, the loudest noise ever recorded was indeed fatal to those who were close enough. On 27 August 1883, the eruption of the Krakatoa volcano in Indonesia created the loudest noise ever measured. It's thought to have been an astonishing 310 decibels at the source. To put this in perspective, a hand drill produces the sound of 98 decibels. The noise produced by a jet engine measures 140 decibels. And the sound of 180 decibels is capable of destroying your hearing tissue. So, the sound Krakatoa produced reached more than 170 decibels at a distance of 100 miles. And sailors aboard a ship just 40 miles from the eruption had their eardrums burst from the sound. The explosion's reverberation was so powerful that it was heard 3,000 miles away. In fact, at a farm in Alice Springs, Australia, over 2,200 miles away, sheep farmers reported hearing what they thought were gunshots. The sound from Krakatoa traveled around the world multiple times. Although no one heard the explosion beyond 3,000 miles, spikes of atmospheric pressure were recorded in places as far away as Canada and England. Those must have been the sound waves produced by the eruption traveling around the globe. Sound above 150 decibels can potentially cause life-threatening harm. In particular, sounds between 170 and 200 decibels can result in lethal conditions, including burst lungs. Anything over 240 decibels could cause fatal injuries, and you don't even want to know what those are. I'll just say that those sometimes happen to cartoon characters, but rarely to people. The scientific explanation behind this is that sound is essentially a wave of pressure, which can travel through both solids and liquids. And, in the case of an incredibly loud sound, pass right through the human body. If the pressure from such a sound is high enough, it can rupture eardrums and internal organs, causing significant and often fatal damage. Now, you probably know how volcanoes sometimes have small earthquakes before they erupt. Well, they often produce this weird sound called a harmonic tremor. The sound kind of hums, and the frequency of the hum gets higher and higher until it suddenly stops just before the volcano erupts. The sound has been recorded at a bunch of volcanoes around the world. But the thing about Redoubt Volcano in Alaska is that its tremor is so intense, people can actually hear it. It's like the volcano is letting out this crazy scream right before the eruption. According to a geophysicist at the University of Washington, the frequency of Redoubt's harmonic tremor is so high that it is barely perceptible as a low bass hum, and that's at its highest pitch. All because the pitch of Redoubt's tremor exceeds that of any other recorded volcano. It questions the limits of the existing models used to explain these phenomena. That's why researchers had to propose a new model to account for these unusually high-pitched tremors. Most volcanoes produce sound when magma bubbles vibrate as they rise through cracks in Earth's crust. But in the case of Redoubt, scientists believe that the harmonic tremor and associated earthquakes occur when magma is forced through a narrow opening under immense pressure. The thick magma sticks to the rock surface inside the conduit, a channel or a pipe that carries magma from a reservoir or chamber to the vent. As the pressure builds, the magma moves upward. This makes it stick again until the pressure forces it to move once more. These sudden movements cause small earthquakes, which, as the pressure increases, occur more rapidly and blend into a continuous rising noise. So it's actually the rocks making the sounds. This new model is important because it could help scientists better understand the eruptive cycles of volcanoes like Redoubt. It could also serve as a limited early warning system. By the time Redoubt began to scream like this, the volcano had already been erupting for a few days. So the tremor might only provide a few minutes or hours of warning before the next explosion. The harmonic tremor at Redoubt reaches an extremely high frequency, then falls eerily silent before the volcano erupts again. This pause occurs when the earthquake activity slows down and the two sides of the fault slip smoothly against one another. Maybe that's when even earthquakes can't keep up anymore. The new model may also apply to other volcanoes, such as the Soufriere Hills volcano on the Caribbean island of Montserrat. The research team is now planning to investigate why the pressure at Redoubt is concentrated in one specific spot. To move ahead in their research, the scientists have created 2 recordings of Redoubt's seismic activity. The first, a 10-second recording, compresses about 10 minutes of seismic sounds and harmonic tremors, sped up 60 times. The second, a 1-minute recording, condenses roughly an hour of activity, including more than 1,600 small earthquakes that had occurred before Redoubt's first explosion with harmonic tremor. These recordings could provide crucial insight into the dynamics of volcanic eruptions and the signals that precede them.
Imagine standing in the middle of Europe 40,000 years ago. The landscape is rough, cold, and unforgiving. Fast food is scarce, and there's no internet. Suddenly, from out of the woods steps a figure, stocky, strong, and with a face that is quite unusual. This human looks similar to us, but something about them is different. Their brow is heavy, their nose is broad, and their body seems to be built to fight nature itself. Well, congrats! You've just met a Neanderthal. You might have thought that Neanderthals were basically ancient humans, but that's not really true. We come from the same genus called Homo, but we, all modern humans, belong to one same species called Homo sapiens. However, there used to be lots of human species before, and Homo neanderthalensis was just one of them. And they actually were kind of cooler than us. So what in the world has happened to them? Neanderthals lived for a long time, for about 360,000 years, across Europe and parts of Asia. 40,000 years ago, the place we now call southern Italy was sitting on top of a huge disaster, a massive supervolcano called Campi Flegrei. This big boy is huge, about 9 miles wide. That's about 10 to 20 minutes in a car to get across it all. But there were no cars then, remember? At the time, it was quiet for a while, but one day, suddenly, it blew in what became one of the biggest volcanic eruptions Europe had seen in 200,000 years. The catastrophe was so crazy that ash, gases, and debris altered the climate across the entire continent. What comes next is usually called a volcanic winter. Average temperatures drop, the sky gets darker, and life becomes even harsher than it already is. The eruption, known as the Campanian Ingembrite, caused Europe to cool by as much as 7 degrees Fahrenheit. Doesn't sound like much? Well, the drop of even 1 degree would cause winters to become harsher, causing horrible snowfall, rains, and floods. Crops would struggle to grow, leading to food shortages. The weather would go wild, too, with storms and droughts. Hey, kind of like now. Except multiply this by 7. Events like these caused some huge chaos in modern times. You can imagine what it did to the Neanderthals. But in reality, a simple volcanic eruption shouldn't destroy an entire species, right? Well, yes. The truth is, the Neanderthals were already hanging by a thread back then, and all because of us. They've been in a tough spot for a while. They lived in places that are now parts of Europe, Western Asia, and the Middle East. Modern humans, us Homo sapiens, entered Europe and were giving them some serious competition for food and shelter. Homo sapiens were sneaky dudes, better at finding food, easily adapting to different environments, and using more advanced tools. We were pushing Neanderthals out, trying to get the same resources. We literally made their extinction a slow and very unpleasant process. So, while the volcano definitely made things worse, it wasn't their only problem, and they didn't completely disappear after the eruption. Some of them hung on in isolated places, like Gibraltar, for another 12,000 years. That's because it's likely most of the severe cooling actually happened farther east, away from where the Neanderthals were trying to survive, and it didn't hit their homes as hard as we thought. In fact, the eruption may have even helped them, at least for a while. Some scientists say that the volcanic fallout might have slowed down modern humans' expansion into Neanderthal territory and gave the poor fellas a little more time to survive. So, the Campi Flegrei eruption was a nasty event, but it only delayed the inevitable. Campi Flegrei is a wild card. It's also known as the Fields of Fire. The air itself there is thick with legend. The Greeks and Romans believed this volcano was the gateway to the underworld. Even an ancient Roman poet, Virgil, Hey, Virgil mentioned this in his famous story, the Aeneid. The hero Aeneas must descend into the underworld, and this place is exactly where he starts. Back in the day, this landscape was full of Roman villas, spas, and fish ponds. The elite had the time of their lives there. What they didn't know, though, was that they were standing on treacherous ground that could go crazy at any moment. The Campi Flegrei is not your typical volcano. You'd imagine a single towering peak, but the landscape looks deceivingly calm, with small features popping up here and there. But if you flew above it, the sight would be insane. A gigantic circular basin, peppered with volcanic cones and craters, like scars from the Earth's violent past. The danger here lies in its subtlety. The ground beneath your feet is constantly shifting, even when you don't notice it. Every so often, the land rises, only to sink again, sometimes by several feet, as magma or gas moves beneath the surface. It's incredibly creepy. The risk is almost invisible. The Campi Flegrei is a massive depression formed by two colossal volcanic eruptions. One of them was the one that cooked Neanderthals, and another happened 15,000 years ago. The most famous eruption, though, happened in the 16th century, and it was horrifying. The year was 1538. For years, the people of Paswali had noticed something unsettling. Land that once sat below the waves was slowly rising. What was once the sea had become new ground. Rumblings from deep within the earth were terrifying, but had become a normal part of life. Earthquakes started in the early 1530s, small at first, but in just 8 years, they became the norm. Until one day, on September 28th, horrifying tremors shook the ground. By the next evening, as the sun dipped below the horizon, a massive crack ripped open the earth near the ancient Roman town of Tripurgoli. From this gash spewed fire, smoke, and a rain of volcanic ash miles away. It was thick and muddy, likely mixed with underground water. The ground trembled as hot pumice rock was thrown high into the air. And then a new mountain began to rise from the land. This was the birth of what we now call Monte Nuovo. Eventually, things seemed to calm down, as if the earth was catching its breath. For days, things seemed quiet. Locals relaxed a bit. They began to approach the new mysterious volcano, a crater with something that resembled boiling within it. People visited it like a new attraction. But then, just days later, the disaster struck again. At night, without warning, a new mountain went wild. A blast from the southern flank hurled scoria, chunks of jagged volcanic rock, into the air. This one was fatal for 24 people. The debris found afterwards was huge and coarse. For centuries after, the only signs of life from the Monte Nuovo were small fumaroles, jets of gas seeping from the earth. But then, even those faded away. Now it's just a lush green cone, a pretty sleeping giant. But the ground near Naples, Italy, is still alive. The Campi Flegrei sits quietly for now, but it might not be for long. It's showing signs it might be waking up again. This supervolcano looks like a hellish landscape, with its boiling mud pits, geysers, and steam vents. Romans and medieval Christians once believed it was a gateway to the underworld, and who can blame them? What's spooky is that recently scientists detected unusual activity under the surface. In 2012, Italian authorities raised the alert level on the volcano from green to yellow, meaning that it needs close monitoring. There are certain changes that usually happen before an eruption. The magma below starts releasing gases, which could weaken the rock above, eventually triggering a disaster. Unfortunately, no one can predict exactly when or if it will erupt. But if it does, the consequences could range from a minor inconvenience for locals to a global catastrophe. Its last tiny eruption happened in the 16th century, and it wasn't too bad. But if history repeats itself, like it was with Neanderthals, we're all cooked. An eruption like that could lead to global cooling, crop failures, and widespread famine. Right now, a group of scientists is trying to get a clearer picture of what's happening beneath the surface. The Campi Flegrei Deep Drilling Project is working to drill a 10,000-foot borehole hoping to check out the magma chamber up close. But at least for now, the supervolcano remains quiet, and let's hope it stays that way.
When you think of a volcano, what's the first thing that comes to mind? Streams of red, steaming hot lava pouring over the sides? Dark clouds of ash rising high into the sky? Maybe you think of a relaxing hot spring. Ah, that's nice. Well, we all imagine one thing, a cone-shaped mountain looming over the horizon. But it can be as green and lush as any other mountain. At the top, of course, there's a giant hole, like an opening that goes all the way down. Inside, there's lava and gases being pushed outside. Lava is so hot that if you were standing at the top of the volcano and looked down, your face would feel as red as the color of that liquid rock oozing out. A volcanic eruption never comes without consequences for us. And I'm not just talking about people living nearby. The impacts are usually felt on a global scale, too. Can't fly for a while because of the blanket of ash released in the air. Not to mention, it might be a bit tricky to breathe. Carbon dioxide, sulfur dioxide, and plenty of other toxic gases whose names immediately take you back to your high school chemistry class. Funny enough, most of that cloud rising out of a volcano is just water. Well, vaporized from those scalding temperatures. But before any volcano erupts, it goes through stages like an angsty teen. First, magma, that's lava before it erupts onto the surface and gets its name change, starts moving underneath the volcano. This causes earthquakes that get worse and more dangerous over time. Then, steam and different gases start spewing out of holes in the planet's crust. Our Earth resembles a tea kettle about to whistle. When the gas emissions and earthquakes get more massive, it usually means the volcano is about to blow its top. But those first stages can take years before an eruption happens. Then, the magma starts building up. With more and more pressure, it's planning to make its great escape. It's hard to notice this happening if you don't have the proper equipment. Good things scientists do, and they've got us covered. The volcano becomes more active by the minute. Ash starts coming out and spreading in the air, creating ominous clouds that turn day to night. With the magma building up, an eruption is imminent. Then, boom! The surface gives in under the pressure below. The magma makes its exit. It's now lava, spewing out the top and flowing down the sides of the mountain. None of this sounds very appealing. So, what if it never happened? What if there were never any volcanoes at all? Would Earth still be the same? Not at all. If volcanoes never existed, there wouldn't be an atmosphere. When our planet was still just a young pup, volcanic gases are what created our protective bubble that allows you and me to breathe right now. They also played a big part in shaping the land and oceans. 4 billion years ago, Earth was still forming. It didn't look anything like the pale blue dot we know today. It was red hot, and the water was trapped under the crust. It wasn't until the surface started to cool down and solidify that the water was finally able to escape. Volcanoes acted sort of like a tear in the fabric of our planet. Water vapor would condense in the atmosphere and then fall back down as rain. It rained for so long that the third planet from the sun started turning into the blue ball we're more familiar with. In fact, there's even a theory that all the water on Earth came from volcanoes. And without water, of course, life wouldn't have been able to form. Land formation went through a similar process. You see, our planet was a pretty rough place to be when it was forming. It was a molten surface with fields of lava and constant volcanic eruptions and space rocks always crashing into it, because there was no atmosphere to protect it. When it started cooling down, a good solid surface formed, but the hot material underneath was still boiling and bubbling, and it continued making its way up. The crust would move and form thick layers with the material that was rising up. Over time, these layers became more permanent. Volcanic eruptions were still happening, but the first landmass had finally formed. Okay, we'll take the best part of volcanoes, an atmosphere. So what if they stopped erupting long after we got our protective breathable shield? Still not good. For starters, volcanoes created the most fertile soil. Around Naples, you have the famous Mount Vesuvius. The soil quality there is incredibly rich, and that's thanks to two huge volcanic eruptions, one that happened 35,000 years ago and another 12,000 years ago. Sure, these volcanoes caused a lot of short-term damage, but in the long run, these soils were fertilized by them. Now the region grows all kinds of citrus fruits, olives, grapes, cherries, and of course, their staple, tomatoes. There'd be none of that without rich volcanic soil, and Naples is by far not the only example like this. Bacteria, the first living organisms, lived in hot water. Scientists have discovered fossilized microorganisms older than 4 billion years. They thrived in hydrothermal vents. Those are fissures on the sea floor, and they're usually near volcanically active places. This means that without volcanoes, we wouldn't have land, water, or even the first life forms that, as the theory goes, would eventually evolve into all the creatures we have today. Could life have still developed on Earth without these explosive mountains? Doubtful. Okay, fair enough. We want our atmosphere and life. So let's say volcanoes stopped erupting today, after we already have all these benefits. Well, we're sort of already there, based on this story. At the start, there was only one continent, Pangaea. It was a supercontinent surrounded by one massive continuous superocean. Volcanic activity by this time had finally calmed down, and this meant all that energy would gather below the Earth's crust. Here's a little diagram. First, we have the Earth's inner core. Then there's the outer core. Next up, we have our convection currents. Magma is next in line. After that, the oceanic crust. And at the very top, we have our ocean and our continental crust. The reason Pangaea eventually broke up into the separate continents we have today is because of plate tectonics. It's not like the crust is all one solid piece. It's broken up into big chunks, or plates, that are always moving. And it's all still moving today. Yes, the land you're standing on right now is sort of surfing on that layer of convection currents. It's a slow process, so it's not like you can feel it. Pangaea didn't break apart all at once. It took tens of millions of years. When the plates move, they cause earthquakes and volcanic activity. They create mountains too. It's good for our planet as well, because the Earth gets to sort of renew its old crust. If there was no volcanic activity now, the pressure underneath the Earth's crust would keep building up. It'd get to a boiling point the continents couldn't handle anymore, and eventually, they'd start splitting into more numerous and smaller masses. Volcanoes are still useful to us till this day. For one, they cool our atmosphere. Their eruptions release sulfur gas. It combines with water in our atmosphere and cools it at its lowest level, which is where we live and breathe. There's also an excellent use for their heat. Geothermal power plants harness the energy coming from deep inside the Earth and turn its heat into steam. We then use that steam and turn it into electricity. This is the case for our friends in New Zealand and Iceland, since they live in places with high underground temperatures. Volcanic material can also be made into blocks for building stuff. It can be grounded down to make cement too. If we want, we can even search volcanoes for precious minerals like gold, copper, and sulfur. And who can forget about hot springs? Tourism to places like Yellowstone and Iceland wouldn't be the same without them. And who doesn't love a nice steamy dip in the ones safe for swimming? Oh yeah. In the end, volcanoes aren't so bad after all. Our beautiful Earth wouldn't be what it is without them.
The largest volcanic region on Earth is not in Africa or Japan, but under the ice of Antarctica. Scientists found 138 volcanoes in its western part, and if they decide to go wild, you'll surely notice it. They could melt huge amounts of ice that will move into the ocean, raise its level, and make our planet uninhabitable for humans. But before you pack your things to fly away to another planet, hear me out. Only 2 of the Antarctic volcanoes are officially classified as active now, and it would take a whole series of eruptions, decade after decade, to seriously impact the whole world. Mount Erebus, one of the two Antarctic volcanoes currently in action, proudly bears the title of the world's southernmost active one. It has been continuously erupting since at least 1972. It emits plumes of gas and steam and sometimes even spews out rocks, and scientists call it Strombolian eruptions. One of the coolest features is a lava lake in one of its summit craters, with molten material on the surface. Such lakes are rather rare because they need certain conditions to make sure the surface never freezes over. The second active volcano is Deception Island, a horseshoe-shaped landmass. It is the caldera of an active volcano that last erupted over 50 years ago. Scientists who monitor it say it shouldn't go wild anytime soon. Antarctica also has plenty of fumaroles. Those are volcanic vents that release gases and vapors into the air. In the right conditions, they can spew out enough stuff to build fumarolic ice towers up to 10 feet tall. Scientists keep an eye on the Antarctic volcanoes with seismometers that detect when the Earth starts trembling from volcanic activity. Sometimes they also use more complicated tech, but it's all really challenging because of how far away this polar region is and how tricky it is to get there. That's why no one can predict when one of the continent's volcanoes that are now sleeping might erupt. We can guess what this waking up would look like if we analyze the events from nearly 20,000 years ago. So, shall we? One of Antarctica's sleeping volcanoes, Mount Rainier, had a series of eruptions and spewed out a good amount of halogens rich in ozone back then. Some scientists say these events warmed up the southern hemisphere. Glaciers started to melt and help finish the last ice age. For these events to repeat, we'd need a series of eruptions with substances rich in halogens from one or more volcanoes that are now above the ice. It's an unlikely scenario, but since it already happened in the past, it's not completely impossible. As for volcanoes hiding under a thick layer of ice, it looks like their gases would hardly make it to the atmosphere, but they would be strong enough to melt huge caverns in the base of the ice and produce a serious amount of meltwater. The West Antarctic ice sheet is wet and not frozen to its bed, so this meltwater would work as a lubricant and set the overlying ice into motion soon. The volume of water that even a large volcano would generate in this way is nothing compared to the volume of ice beneath it. So, a single eruption wouldn't make a difference. But several volcanoes erupting close to or beneath any of the western Antarctica's big ice streams would. Those ice streams are rivers of ice that take most of the frozen water in Antarctica into the ocean. If they change their speed and bring unusual amounts of water into the ocean, its level will rise. As the ice would get thinner and thinner, there would be more and more new eruptions. Scientists call it a runaway effect. Something like that happened in Iceland. The number of volcanic eruptions went up when glaciers started to recede at the end of the last ice age. So, it looks like, for massive changes, several powerful volcanoes above the ice with gases full of halogens need to get active within a few decades of each other and stay strong over many tens to hundreds of years. Antarctica stores around 80% of all the fresh water in the world, and if they melted all of it, global sea levels would rise by almost 200 feet. And then we'd have to look for a new planet to live on. But this again is an unlikely scenario. It's more likely that the eruptions under the ice will lubricate ice streams and seep water into the ocean, but it wouldn't be the end of the world. A super strong, super angry supervolcano could do it though, and it has already happened in the past. Over 200 million years ago, the world went through a major makeover with not one, not two, but 4 massive volcanic eruptions in huge pulses. The supervolcano called Camp had been erupting over and over for 600,000 years. It all happened in Wrangell, a large chunk of land that used to be a supermassive volcano stretching across what's now British Columbia and Alaska. And it wasn't the lava or the volcanic ash that ruined the environment. The eruption made carbon levels skyrocket. The planet would never be the same again. This volcanic activity might have helped dinosaurs grow from cat-sized critters into giants we saw in Jurassic Park. It kicked off a 2-million-year rainy season. It made the whole world hot and humid, and the dinos just loved it. Researchers dug deep into sediment layers beneath an ancient lake in Asia to uncover these secrets. They found traces of volcanic ash and mercury, clear signs of those epic eruptions. There were carbon signatures showing huge spikes in carbon dioxide levels. It made the atmosphere toasty, and the rain poured down. So the bad news is, another eruption like this could happen. The supervolcano beneath Yellowstone National Park has been sleeping for nearly 70,000 years. But if it wakes up, it would be many times more catastrophic than the eruption of Mount St. Helens in 1980. It's considered the most disastrous volcanic eruption in U.S. history. It followed 2 months of earthquakes and injection of magma below the volcano that weakened and destroyed the entire north face of the mountain. The eruption column went 80,000 feet into the atmosphere and spread ash over 11 U.S. states and several Canadian provinces. The last Yellowstone eruption was 1,000 times greater than that. The ground above Yellowstone sits on a hot spot made of molten and semi-molten rock called magma. This magma stuff flows into a chamber beneath the park, about 4 to 6 miles down, making the ground puff up like a balloon. But then, as it cools down, the ground goes back to its usual state. Volcano watchers have been keeping an eye on this for a century. They noticed the ground lift up about 10 inches around 20 years ago, but since 2010, it's been going back down. The experts say we have no big eruptions on the horizon, so doomsday isn't coming anytime soon. But there's some underground activity going on lately which keeps us interested. Since humans haven't been around to witness every little thing Yellowstone does, it's kind of tough to say for sure what's brewing down there. Yellowstone has had some epic eruptions within the last couple million years. They happen like clockwork, with gaps of 600,000 to 800,000 years between them. The last big one was around 640,000 years ago, and it basically reshaped the entire landscape, spreading ash and debris as far as Louisiana. You can still see the aftermath of the last big eruption in the Yellowstone caldera today. Experts say a massive eruption like the last one is an unlikely scenario. We're more likely to see eruptions of steam and hot water or lava flows. When and with what force it will wake up remains a mystery to scientists.
Imagine this wild scenario. You're up in the sky flying a plane, and all of a sudden, the world stops spinning for 10 seconds. It's like time freezes. First off, let's talk about the physical experience. As the world pauses its rotation, you would feel a sudden absence of motion. The plane, which was soaring through the air just moments ago, would come to a halt. The stillness and silence would be surreal. You might even feel a slight jolt or shift as the forces of momentum would try to adjust to this abrupt change. You'd witness an extraordinary sight if you looked out the plane's windows. The clouds would freeze in place, almost like fluffy paintings suspended in midair. The sun would hang in the sky, casting an otherworldly glow, and the landscapes below, whether it's cities, mountains, or vast stretches of forest, would become eerily static. A rush of thoughts and feelings would flood your mind in that suspended moment. First, there might be a sense of awe and wonder at the sheer strangeness of the situation. You'd be witnessing something that defies the laws of nature, a temporary disruption in the flow of time. You might also feel a hint of anxiety or concern mixed with that awe. After all, you're flying a plane, and suddenly, everything comes to a halt. Questions would race through your mind. What caused this? Is there a risk to the plane or to those on the ground? As the world comes to a halt, imagine the rippling effect of this event on everything around you. On the ground, people would sort of freeze too. Cars would come to an abrupt stop on the roads, giving a sci-fi movie vibe. Imagine the expressions of pedestrians and drivers. In larger cities, bustling streets would transform into an eerie tableau. Time-sensitive activities, like deliveries and public transportation, would also be affected, causing momentary chaos as everyone tries to comprehend what just happened. Nature itself would also be affected. Leaves on trees would hang motionless, caught in mid-rustle. Even the waves of the ocean would pause mid-crash, frozen in their powerful motion. As for the rest of the world, it's safe to say that the phenomenon would captivate global attention. News outlets and social media platforms would explode with reports, videos, and photos of the frozen moments. Scientists and experts from various fields would scramble to provide explanations, theories, and speculations. Filmmakers would make documentaries to explore the global impact of those frozen moments. But let's assume that after those 10 seconds, the world started spinning again, just as unexpectedly as it stopped. As motion is restored, you'd experience a jolt of acceleration. The plane would resume its forward momentum, and you'd feel the forces of gravity and movement return to normal. The landscapes below would begin to move again, almost like a time-lapse video played in reverse. Now, your emotions might shift once more. There could be a mix of relief, excitement, and curiosity. You've just witnessed a truly extraordinary disruption in the natural order. You might be buzzing with questions and eager to find out if anyone else has experienced the same phenomenon. Imagine your conversations with friends and experts, discussing theories and attempting to unravel the mystery behind this bizarre occurrence. Of course, there would be endless speculations about what caused the temporary stoppage of the world's rotation. Maybe it was a scientific anomaly, a cosmic event, or even a glitch in the fabric of reality itself. Okay, in the next scenario, you won't be this lucky. You're just cruising through the sky at 10,000 feet, enjoying the view from your trusty aircraft, when an insanely powerful shockwave ripples through the air. It's like a sonic boom racing upward from the ground at a speed that's even faster than the sound itself. Since you're chilling 10,000 feet above the surface, that shockwave is going to hit you like a speeding bullet in less than a blink of an eye. You're going to get like 2 seconds. Now, when that moment arrives, prepare yourself for the turbulence. You'll be tossed around and smacked against the walls of the aircraft like a pinball in a frenzy. It will be one wild gravity-defying roller coaster ride. If we assume the air itself comes to a standstill alongside the Earth, then buckle up, because you'll be zooming through that frozen atmosphere at a speed of roughly 1,000 miles per hour. Your poor airplane won't be able to handle that insane velocity, and it'll be squished into a sorry pancake before you can even say, "Oh no!" I mean, we're talking about an instant stop, like hitting a brick wall at full speed. The world halting means everything in it, including you, would continue moving at the same speed. Yeah, that's right, you'd be thrown into a chaotic frenzy, like a chair in a hurricane, no matter where you are. It won't matter if you're soaring in a tiny plane, chilling in a subway car, or exploring the great outdoors on a leisurely hike. The grim reality is that your fate is sealed, and it won't take long for it to catch up with you. Now, let's talk about the sheer power behind Earth's rotation. You see, our planet's spin carries an astronomical amount of momentum, which is like a stored energy reserve. If the rotation were to stop suddenly, all that pent-up energy would need an outlet, and the most likely form it would take is heat. It's like unleashing an inferno of thermal energy in an instant. Think about it as the most colossal head-on collision you can imagine, with no airbags to soften the blow. It's an all-out catastrophe of epic proportions. Everything, and I mean everything, would break apart like a fragile porcelain figurine. To put it simply, chaos would reign supreme. Okay, let's start from the very beginning. How do planes fly? 4 key forces keep an airplane soaring in the sky. First up, we have lift. This force is responsible for pushing the airplane upward. You see, the way air flows around the wings actually generates lift. The shape of the wings plays a role too, helping to enhance this lifting force. Next, we've got weight. It's the force that pulls the airplane towards Earth, like gravity in action. To keep things in balance, airplanes are designed to distribute their weight evenly from front to back. Then there's thrust. This force is what propels the airplane forward. It's all thanks to the engines, which provide the necessary thrust. It could be a propeller or a jet engine. Either way, as long as the air keeps flowing over the wings, the airplane keeps moving forward. Lastly, we have drag. You've probably experienced this when walking against a strong wind. Drag is the force that slows down the airplane. These vessels are designed to minimize drag by allowing air to pass smoothly around them. An aircraft can fly when all four forces work together harmoniously. And, of course, we need the pilots. In our previous scenario, it's none other than you. This made me wonder how Earth's rotation affects the speed of an aircraft. It turns out it doesn't mess with the speed of an airplane. Picture yourself on a train. Now, if you jump in the air while the train is moving, do you think you'd land further back because the train kept going? Nah, that wouldn't happen. Airplanes are like that too. They move through the air along with Earth's rotation, so their speed doesn't get affected by it. But here's the catch. The wind at different altitudes can actually intervene with the speed of an airplane. Let's say you're flying from Paris to LA. Depending on the wind, your flight time might turn out to be compared to the other way around. So in a nutshell, Earth's spin doesn't throw airplanes off track, but the wind can influence their speed. The moon's volcanoes are not dormant, and they can erupt any minute. For years, we lived knowing nothing about it, but now it's officially proven thanks to China's Chang'e 5 mission's shocking discovery. The lunar soil samples it brought back to Earth contained something absolutely unexpected, hinting that volcanic eruptions may have occurred on the moon as recently as 123 million years ago. Geologically, that's practically yesterday. But the big question is, are we safe down here on Earth? We've long known that the moon was once volcanically active due to the dark regions, lunar maria, on its surface. These maria, the dark plains that give the moon its characteristic markings, are ancient lava flows that date back to around 3 to 3.8 billion years ago. Until recently, scientists thought that those ancient flows marked the end of the moon's volcanic activity. But the Chang'e 5 mission brought back lunar soil that included several microscopic glass beads, and 3 of them in particular revealed an extraordinary story. They formed around 123 million years ago from volcanic eruptions. An uncertainty range is a mere 15 million years. The discovery of those tiny beads is super important because of their composition and rarity. Measuring between 20 to 400 microns, which is smaller than a grain of sand, these beads are volcanic in origin. And this fact sets them apart from most other lunar glass beads, which typically form due to meteor impacts. Impact events on the moon create glass by melting surface rock with incredible heat and pressure. The result is tiny glass beads scattered all over the landscape. Yet, the volcanic beads identified in Chang'e 5's sample were formed by magma erupting from beneath the moon's crust and cooling it into glass as it reached the surface. By using uranium-lead dating, which measures the decay of uranium into lead within the beads, scientists managed to pinpoint their age with striking accuracy. The results suggest that the last known volcanic activity on the moon happened within the past 200 million years, making it a recent event in the moon's long history. This discovery also aligns with prior observations of unusual surface features known as irregular mare patches. Those are smooth mounds surrounded by rocky terrain. They were first spotted by NASA's Lunar Reconnaissance Orbiter in 2014. These patches appear much younger than other lunar features, potentially formed by volcanic eruptions less than 100 million years ago. Before Chang'e 5's glass beads, these irregular mare patches were among the best evidence of recent volcanic activity on the moon. Yet, without confirmation, their origins remain uncertain. And now, the glass beads confirm volcanic action. The findings raise new questions about the moon's inner workings. In particular, how could it retain enough heat to sustain volcanic eruptions? We thought that the moon had cooled significantly after its formation 4.5 billion years ago, which made it volcanically inactive. And without tectonic activity or an atmosphere, the moon should have shed its internal heat long ago. Yet the beads suggest the possibility of some localized heat sources within the moon's mantle. Scientists think that heat-producing elements such as potassium and thorium might be creating small, warm pockets which generate enough heat to melt rock and trigger isolated volcanic eruptions. But wait, beyond rewriting the moon's history, this discovery adds an intriguing twist to ongoing studies of transient lunar phenomena. These sightings, often reported as ghostly glows or hazes by amateur astronomers, remain unconfirmed by scientific probes. Some experts just dismiss them as illusions caused by Earth's atmosphere. But if the moon has small pockets of volcanic or outgassing activity, TLP might have a real basis. Gases emitted from beneath the surface could explain such mysterious glows and possibly be a hint of residual volcanic action on the moon. Now, if volcanic activity still lingers on the moon, this might have exciting implications for future lunar missions. In the coming decades, astronauts might be able to use volcanic heat for generating power, melting ice into water, or even warming bases built into the frigid lunar surface. But recent geological discoveries aren't limited to Earth's natural satellite. We learn more about volcanic moons beyond our solar system too. The detection of a possibly volcanic exomoon orbiting exoplanet WASP-49b around 635 light-years away means that volcanic activity may be a common feature among moons. Up until now, Jupiter's moon, Io, held the title of the most volcanic body we know about. But researchers at NASA's Jet Propulsion Laboratory may have found a new candidate. This potential exomoon came to light when scientists observed a cloud of sodium gas around the exoplanet. But the thing is, sodium clouds are unusual in planetary atmospheres and can suggest volcanic activity. The sodium cloud near WASP-49b had a bizarre, unexpected behavior. It was moving erratically, shifting size, and occupying a space too large to be explained by the exoplanet's own atmosphere. Scientists thought the cloud could actually be generated by a volcanically active exomoon in orbit around WASP-49b. Volcanic moons like Io are known to release gases such as sulfur dioxide, sodium, and potassium, which form massive clouds around their parent planets. Io, for instance, regularly produces vast amounts of gas that form a cloud encircling Jupiter, up to 1,000 times the size of the gas giant itself. If something similar occurs near WASP-49b, the gas cloud could be a clue to volcanic activity on an exomoon orbiting the planet. Observations from the European Southern Observatory's Very Large Telescope in Chile seems to confirm this theory. The sodium cloud around WASP-49b is positioned high above the exoplanet's atmosphere and behaves in ways that don't match the exoplanet's 2.8 Earth day orbit. This could suggest that it originates from a separate body, likely a volcanically active moon. Additionally, WASP-49b and its host star consist primarily of hydrogen and helium, which makes the sodium cloud even more unusual. The observed rate of sodium release, over 220,000 pounds per second, can be a sign of an immensely powerful volcanic source. If scientists verify the existence of this exomoon, it would be the first discovery of a volcanic exomoon. Back in our solar system, Io remains the main space object, helping us understand volcanic moons. Recently, NASA's Juno spacecraft provided some of the closest images of Io since the Galileo mission over 25 years ago. Io's intense volcanic activity is caused by tidal heating, the result of the gravitational pull of Jupiter and nearby moons, like Europa. This tug-of-war generates immense friction within Io, producing heat that fuels continuous volcanic eruptions. One of Juno's most exciting recent findings was a new volcano that appeared just south of Io's equator. Juno's images show a large, complex volcanic region, approximately 111 by 111 miles in size. The craziest thing? It wasn't there when Galileo imaged the same spot in 1997. This new volcano formed near the previously known volcano, Canacecale. Researchers say that this new volcanic structure is a great change that highlights the dynamic nature of Io's surface. Io's equatorial region is home to most of its volcanoes because of the concentrated tidal heating it experiences. The most powerful eruptions emit sulfurous gases and produce bright lava flows. They cover the moon in colorful, sulfur-rich deposits. JunoCam's image, taken from about 1,570 miles away, shows Io dramatically lit by sunlight reflected off Jupiter. And you can see a stunning view of its constantly changing volcanic surface. Despite these detailed observations, there are still many mysteries about Io's volcanism. Scientists are particularly curious about how tidal heating affects Io's interior, and whether it has a subsurface magma ocean. Plus, researchers try to understand what triggers different types of eruptions. For example, plumes versus lava flows, and how volcanic gases shape Io's surface and thin atmosphere. The study of volcanic moons from Io to the possible exomoon near WASP-49b sheds light on how tidal forces create volcanic activity in different moons. In icy moons like Europa, tidal heating sustains liquid oceans beneath the surface, creating potential habitats for life. But for Io without an ocean, the same forces instead generate powerful volcanic activity. Plus, if volcanic exomoons do exist, like the one possibly orbiting WASP-49b, we might soon discover more volcanic bodies across the galaxy.
Brighter green plants might give us a warning when a volcano is stirring. Turns out, unlike earthquakes, which are super unpredictable, volcanoes can sometimes show early signs. Plants growing around volcanoes look healthier when volcanic activity ramps up because they thrive on increased carbon dioxide levels, a gas that volcanoes emit during eruptions and through underground magma. They also turn browner when the volcanic activity peaks, likely due to harmful gases and heat harming the vegetation. Scientists use satellites to figure this all out. They analyzed satellite data spanning from 1984 to 2022. Future changes might be tracked through satellite imagery as well. Now, this isn't easy to measure directly, especially when volcanoes are tucked away in hard-to-reach, lush areas, such as Taal Volcano in the Philippines and Mount Etna in Italy. This way, plants could give us a heads up about volcanic eruptions years before they happen. With this new weird method, we could save nearby communities by enhancing safety measures, minimizing property damage, and improving evacuation plans. Volcanoes and plants are often tied in mysterious ways. For example, volcanic eruptions in Krakatoa, Indonesia, gave a surprising boost to saguaro cacti in Arizona's Sonora Desert, even though they're thousands of miles away. When the infamous Krakatoa volcano erupted in the 19th century, it sent shockwaves around the world and suddenly helped nurture a generation of saguaros. These incredible cacti can be up to 40 feet tall as adults, but they start life as tiny seedlings that struggle to survive in the desert's harsh conditions. However, thanks to the cooler and wetter conditions caused by volcanic eruptions like Krakatoa, they can get unbelievable growth spurts. Chillier summers and milder winters that follow such eruptions create perfect conditions for young saguaro, which usually don't make it due to extreme heat and cold. But volcanoes not only influence plants, they're also Earth's jewelry makers. Deep beneath the surface, in the fiery heart of a volcano, conditions are just right to form dazzling gems. When volcanoes erupt, they can bring these treasures up to the surface. One of the most famous gems created by volcanic activity is the diamond. They're usually found in a rare type of volcanic rock called kimberlite, which forms deep within the Earth under extreme pressure and temperature. Millions of years ago, kimberlite eruptions, small but powerful volcanic events, hauled diamonds from deep within the Earth. This created sources for many of today's diamond mines. Now, these eruptions didn't happen just anywhere, but originated from the stable hearts of continents, known as cratons. They were bursting forth from as deep as 75 miles underground. Fueled by a mix of carbon dioxide and water, they were like natural rockets, blasting through the Earth to form carrot-shaped channels filled with diamond-laden rocks. Recently, scientists have delved into why these eruptions happen. They suggested that the breakup of ancient supercontinents like Pangaea disrupted the mantle's flow underneath, triggering these spectacular kimberlite eruptions. When a volcano that hosts kimberlite erupts, it can propel these precious stones toward the surface, where we eventually find them. There are other gems that can be found in solidified lava, like peridot, a bright green stone that forms in the molten rock of the upper mantle and is brought to the surface by volcanic activity. There's also obsidian, a shiny glass-like rock that forms when lava cools rapidly. And then there are some insane rocks, like the ones that can hold water in them, even in lava. The deeper we dive in volcanoes, the rarer are the gems we can find. If we dive into the thick layer known as the mantle, we might find olivine, a resilient, pretty green mineral that makes up about half of this layer. It loves high temperatures and happily forms in lava, eventually crystallizing into the igneous rocks we find scattered across the Earth's surface thanks to volcanic eruptions. As olivine cools, it starts to crystallize. Sometimes these crystals are tiny, but other times they grow large and can be polished into beautiful gemstones used in jewelry or industrial processes like metal casing. But as we venture deeper, about 250 miles down, olivine undergoes a fascinating transformation. Here we encountered the layer that's called the transition zone. In the transition zone, the pressure is intense and the heat is on the rise. In this place, olivine morphs into exotic materials like wadleysite and ringwoodite. They show a lovely blue-green hue and a glossy sheen. While they're too rare and small for jewelry, they have a unique ability to hold water within their structures, not as droplets, but as hydrogen and oxygen components, making up to 3% of their volume. Later, it turned out that the transition zone is not just a pressure cooker for minerals, it's a giant sponge, holding a vast underground water reservoir. This was a groundbreaking discovery. You get the pun? This hidden water doesn't form an ocean as we know it, but suggests vast amounts of water are stored deep within the Earth. Volcanoes can help us learn more about life not only on our planet, but on others as well. In the fiery heart of Costa Rica's Poas volcano lies Laguna Caliente. This hydrothermal crater lake is among the most brutal environments on Earth. We've got a whole bunch here: scalding temperatures, toxic minerals, and water so acidic it can corrode metal. But despite all that, there's a few tough microorganisms that manage to thrive in these conditions. And this remarkable survival has caught the attention of scientists because it might just hold clues about life on Mars. Scientists are studying these extreme microbes. Turns out they've developed a myriad of genetic adaptations to withstand their harsh surroundings. They have genes that help them process everything, from sulfur and iron to carbon and bioplastic granules. All these things could be crucial in environments as challenging as Mars. NASA's Perseverance rover is currently exploring the crater rim of Jezero crater on Mars. Previously, we looked for Martian life signs in places like old stream beds and river deltas. However, the discovery of Laguna Caliente suggests that we should probably look for life in the remnants of ancient Martian hot springs as well. These spots might have once had the right cocktail of heat, water, and energy sources that are thought to be essential for kickstarting biology. Volcanoes can help planets in many ways, but they can also destroy life. Scientists believe that volcanic activity was one of the main reasons for at least 3 of Earth's 5 mass extinctions. Take the mass extinction of dinosaurs. We're used to blaming it on the Chicxulub meteorite, but there's a chance it could have been caused by volcanoes. The consequences of the eruptions can be horrifying. Mount Tambora, located on the Indonesian island of Sumbawa, erupted in 1815 and was the most powerful eruption ever recorded in history. This massive eruption was so strong it ejected between 8 to 11 cubic miles of material. It was so loud that the sounds of the eruption were heard as far away as Sumatra, over 1,600 miles distant. Before its catastrophic eruption, Tambora had been dormant for centuries, and its magma chamber slowly cooled and crystallized. This process built up immense pressure inside the volcano. It was eventually released in a series of terrifying events starting on April 5, 1815. The climax came on April 10th, when massive plumes of ash and pumice were thrown into the atmosphere. The aftermath of the eruption was dire. Tsunamis devastated the surrounding area. It's estimated that around 4,600 people passed away immediately from the eruption itself, with ash fallouts affecting air quality and water sources across the region. This event came down in history as the year without a summer. This was due to the vast amount of sulfur dioxide Tambora ejected into the stratosphere. It created a veil of aerosols that reflected sunlight and significantly lowered global temperatures. A similar thing happened to our planet 66 million years ago, during the dinosaur extinction. The sky turned black for months. I mean, I wasn't there, but that's what they say.
Fraser Island sits off the coast of sunny Queensland, Australia. But don't fall for its beauty. It's home to the most dangerous beach in the world. There's nowhere on the island to seek medical attention. If you do run into danger, you're on your own. Dingo attacks are super common here. If you don't know what a dingo is, it looks like an adorable dog. But beware, this wild breed is extremely dangerous. And the dingo's gnashing teeth aren't the only thing to be scared of. The seas around the island are swimming with great white sharks. There's jellyfish in the water too. Fraser Island is home to some of the world's most dangerous kinds, including the Portuguese bluebottle. One sting from its venomous tentacle is enough to take down an adult human. Even if you manage to avoid the creatures on the island, the sea itself is perilous. The waters are incredibly rough and have powerful riptides. These are strong currents that will pull you away from the shore. And remember, there are no lifeguards to come to your rescue if you get in trouble. Even the sand is dangerous. Car rollovers in the thick dunes happen all the time. It's definitely best to swap your car for a dune buggy. Travelers also often drive down the dunes straight into the lakes below, but the lakes are incredibly shallow, which is not very safe. Fraser Island is also known for its beautiful lookout points, but you'll need to watch your step. You might feel on top of the world, but stay well away from the edges as jagged rocks and crashing waves line the shore below. There's an island in Brazil known as Snake Island, which is equally dangerous. I wonder what the hazard could be here. It's home to thousands of golden lancehead vipers, which are one of the most venomous snakes on the planet. They grow to over 20 inches long, and their fast-acting venom melts the flesh from around their bites. There are around 4,000 snakes on the tiny 106-acre isle. Snake Island has become so dangerous that the Brazilian authorities had to ban everyone from going there. For years, the only human inhabitants to brave the island were a lighthouse keeper and his family. But local legend says that one night a group of snakes crawled in through a window to attack, and the family was never seen again. Known as the gas mask town, the island of Miyake-jima is not one to visit in a hurry. It's home to a fiery, active volcano that has erupted several times over the past few years. There were several massive eruptions leading to the spread of a highly poisonous gas across the island. Residents are now required to carry gas masks at all times, and a terrifying alarm blares across the island whenever the poison levels get too high. The island is also in the middle of the Devil's Sea. Ships mysteriously vanish in the area, and experts have no idea why. The North Sentinel Island is home to a remote and unwelcoming tribe. They lived alone on the island without any modern technology or contact with the outside world for over 60,000 years. And that's just the way they like it. They've been known to fire arrows at anyone who attempts to enter the island. There are many stories of people visiting the island, and they are never seen again. It's not ghoulish ghosts or slithering snakes that you have to worry about on the Caribbean island of Saba. It's hurricanes. The tiny island has been hit by more severe hurricanes than anywhere in the world over the last 150 years. There have even been 7 tropical cyclones, which is an intense circular storm. The winds in these storms can reach 254 kilometers an hour. Try standing up in that. You'll also struggle to find a pilot who'll even land on the island. It's incredibly dangerous not because of the winds, but because it's home to the shortest runway in the world. It's only 440 yards long. 2 huge rocky ridges surround the runway, so there's no room for mistakes. The Kilauea beaches of Hawaii used to be one of the most dangerous in the world. The Kilauea volcano has been almost consistently erupting for the past 35 years, spewing red-hot lava into the surrounding waters. The water temperatures have even passed boiling point as a result of the lava. Happily, it's no longer active. While the island of Bikini Atoll might sound like the perfect summer vacation destination, it's most certainly not. The problem is that this place has dangerously high radiation levels, and the locals had to leave it. Although the island was declared safe in the 90s, its original inhabitants have refused to return. The lack of fishing in the area has also led to a massive increase in sharks who swim the waters in search of their next meal. Strangely, the corals and reefs are thriving. From the distance, Ramree Island looks idyllic. White sand, swaying palms. But beware. They say thousands of hungry saltwater crocodiles used to lurk there, ready to strike at any time. The exact number of those animals was unknown, and some scientists claim that there are quite a few of them right now. I'd stay well clear of the island though. I don't really feel like becoming crocodile food. Skeleton Coast in Namibia is appropriately named as the harsh landscape and lack of water make life almost impossible. Whale carcasses, turtle shells, and elephant rib cages litter the shore. If that isn't bad enough, lions and hyenas patrol the beach in search of their next meal. The surrounding waters are just as dangerous, as they are home to 11 different species of shark. Many sailors have become lost on this coast and have never been seen again. Cape Tribulation in Australia also lives up to its name as it is packed, full of dangers. Swimmers have to wear special stinger suits because the water is teeming with stinging jellyfish. Saltwater crocodiles also hide in the water, but they don't make a suit to keep you safe from those. It's not just the jellyfish that sting. The area is covered in stinging trees. The trees have jagged leaves that give the crocs' teeth a run for their money. On land, there's angry cassowary birds. There are flightless birds that are the same size as an ostrich. They have sharp talons that can easily slice through skin. The Utterkleiv beach in Norway is one of the best places to see the northern lights, but you'll be lucky if you survive more than one night there. The seas surrounding the island can reach 46 degrees Fahrenheit, and that's just in the summer. It probably feels like swimming in ice cream. For years, Gansby Beach has remained a habitat for the most dangerous creatures on the planet. Sharks are particular fans of its waters, and the coastal stretch is known as the Great White Shark Capital. The sharks are attracted to the 60,000 sea lions that flock to the beach every year. Not just shark food, wild sea lions can be unpredictable and aggressive towards humans. Comoro Islands are the worst vacation destination for those who don't really like mosquitoes. The place is swarming with the little guys. Locals say all the water on the island must be contaminated because of them. So they like to sterilize water before drinking, making ice, and even brushing their teeth. If you're really into coconuts, there's one place you should probably go to grab some. I'm talking Danger Island. Yep, it's the real name of one of the islands in the Chagos archipelago. It shouldn't scare you off though. The major problem it has is parking. I mean, safe anchorage for those who come there. Finally, while it may sound dreamy, you're probably going to want to avoid the beaches of the Amazon. Sharp-toothed red-bellied piranhas, anacondas, and electric eels are just some of the beach's regular residents. It has one of the widest varieties of animal species on the planet, including the Amazonian giant centipede, which has a poisonous bite. It's not just the animals of the Amazon that you have to watch out for. Strychnos and curare are the two Amazonian plants that are super poisonous.
One of the few places you haven't traveled to yet is a volcano. It's an opening in the Earth's crust through which hot gases, molten rock, and other stuff get to the surface of the planet. But which one should you choose? There are different kinds of them. For example, shield volcanoes are built almost entirely of solidified lava flows, or lava domes formed by small masses of lava that are too thick to travel great distances. You can also pick a cinder cone. It's the simplest kind of volcano out there. It's built from blobs of almost solid lava that erupts from a single vent. This lava is ejected into the air with great force. Then it breaks into tiny fragments that become solid and fall back as cinders. With time, they form an oval or circular cone around the vent. Such cones rarely rise more than 1,000 feet. But what if you choose something even more impressive? How about traveling down a stratovolcano? Huge, steep-sided, and powerful. Once you've made your choice, you also decide to opt for an active volcano that is erupting at this very moment. What you're observing now is called a glowing avalanche. The volcano has just erupted a huge portion of lava, which has created a pyroclastic flow. Its temperature can reach an insane 1,300 degrees Fahrenheit. You see how this flow gets formed from rock fragments and surges down the flank of the volcano at a speed of several hundred miles per hour. Ash is raining down on Earth like grayish, powdery snow. Volcanic ash consists of tiny particles of pulverized rock, volcanic glass, and minerals. When the ash gets mixed with the water from mountain streams and rivers, raging mud flows appear. Despite how scary it all looks, you get closer. Good thing you're wearing a protective suit that can withstand any temperature. The nearer you get, the more fumaroles you spot. These are holes and cracks at the base of the volcano and in its slopes. They emit huge clouds of steam and volcanic gases, carbon dioxide and sulfur dioxide. Some of the cracks are so large, you can probably squeeze through and sneak a peek inside the volcano. But you have a different destination, the crater. On your way there, you spot a strange conical structure on the side of the volcano. It looks like a horn growing on the main cone. It must be a secondary cone, also known as a parasitic cone. Such cones form around secondary vents that reach the surface of large volcanoes. In this case, an eruption can occur not only through the main vent at the top of the volcano, but also through these additional vents. In any case, that's not where you're heading. Soon, you reach the crater. It's a massive circular basin. When you go to its edge and look inside, you see it's also very deep. The lava vent, which is where you need to go, is at the bottom of the crater. But even before jumping into the vent, you spot some strange tubes hiding under the lava flow. Those are lava tubes, natural passages through which fresh liquid lava travels beneath the surface of the lava flow. You decide to make a detour and follow one of the tunnels. It's the main lava tube. You also spot several smaller tubes. They supply lava to one or more lava flows. If the volcano wasn't erupting at the moment, the lava would drain downslope from this tube system. The passages would have lava marks on the walls, a flat floor, and lava stalactites hanging from the ceiling. But even now, there's some empty space above the flowing lava. That's because it has eroded downward, making the tube deeper. But right now, you need to get back. You take the next turn and get back to the crater. You wait till the volcano spews another portion of boiling lava and dive into the volcano's throat. It's the entrance of the volcano. Lava and volcanic ash get ejected from here. The volcano's throat is wide, and you easily travel deeper down. The lava around you glows bright red and orange. That's because when it first bursts to the surface, its temperature can reach 2,200 degrees Fahrenheit. That's hot enough to melt iron. You move down the volcano's main vent. It's a weak point in our planet's crust. There, scorching hot magma manages to escape from its chamber and reach the surface. While going deeper and deeper into the vent, you notice sills. Sometimes, lava intrudes between the crack in the crust, pools there, and crystallizes. This creates deposits of ash and solidified lava. That's what sills are. Pretty soon, you reach a magma chamber. It's a large pool of molten rock. The one you're in at the moment is quite shallow. That's because it's not the main one. After traveling several more miles down through the vent, you get to another huge magma chamber. It supplies the small one beneath the base of the volcano. The main magma chamber lies in Earth's crust, which stretches from 3 to 44 miles deep. The molten rock there remains under extreme pressure, and the temperatures inside are incredibly high. With time, the rock surrounding the magma chamber starts to break and fracture. This creates outlets for the magma, and since it's made of a much less dense material than the surrounding rock, the magma begins to seep through the cracks to the surface. From the main chamber, it rises to the upper one. Then it makes its way to the surface in a powerful eruption. You explore the magma chamber and then decide to go even deeper than that, to the place from where all that molten rock gets into the magma chamber. You're moving through the crust. The volcano is located on land, That's why your trip takes longer than it would if you were traveling through the oceanic crust. It's only 3 to 6 miles wide. But the continental crust is much thicker. It can be 28 miles thick in some places. As you're going through the crust, you can't but notice its light color. That's because it consists mostly of granite. If you were going through the oceanic crust, the material surrounding you would be dark or nearly black because it has a different composition. The deeper you go, the hotter it becomes. Sure, the temperature here isn't as high as in the magma chamber, but still, at the boundary with the mantle, your thermometer shows 750 degrees Fahrenheit. At a depth of about 20 miles, you reach the boundary between the crust and the Earth's upper mantle. There, the pressure reaches a mind-boggling 10,000 atmospheres. That's where magma comes from. You could finish your journey and get back to the surface, but your curiosity gets the better of you. You decide to go deeper, all the way to the center of the Earth. The next layer on your way is the mantle. It makes up 2/3 of the Earth's mass and 84% of our planet's volume. It's 1,800 miles thick. The rock closer to the inner part of the mantle is semi-solid, like caramel candy. The upper part of the mantle, as well as the crust, is broken into massive pieces. They look like a colossal jigsaw puzzle. Those are tectonic plates. They drift at a speed of 1 to 2 inches per year. You're moving through the upper mantle and feel the temperatures rising up to 1,600 degrees Fahrenheit. Near the boundary with the core, the temperature is already as high as 7,000 degrees Fahrenheit. The pressure in the lower mantle reaches 240,000 atmospheres. You'd feel the same pressure if 3,300 elephants made a tower on your head. At a depth of about 1,800 miles, you see the boundary between the mantle and the outer core. The insides of the planet around you are heated up to 9,000 degrees Fahrenheit. Such temperature is high enough to keep the outer core liquid. The pressure there is almost 2 million atmospheres, but it's not enough to make the iron that the core is made of solid again. The outer core is 1,500 miles thick. It churns in massive turbulent currents and generates a magnetic field. In the outer core, Earth's magnetic field is 50 times more powerful than at the surface. You are now more than 3,000 miles underground, and you've reached the inner core. It's a solid metal sphere, around 1,500 miles across. The inner core is immensely dense and spins faster than the rest of the planet. The temperature there is as high as on the surface of the sun, 9,800 degrees Fahrenheit. And the pressure inside the inner core is 3 million times greater than on the surface. It took about 500 million years for the inner core to form, which means it's younger than some parts of the crust.
Quakes volcano in Indonesia is not your ordinary lava-belching mountain. Instead of producing black smoke and red lava, as most volcanoes do, this eccentric guy lets out a blue flame and electric blue lava. This phenomenon occurs because the volcano contains some of the highest levels of sulfur in the world, and when the sulfuric gases interact with scorching air and get lit by the molten lava, they start to turn blue. Unfortunately, you can see this mesmerizing sight only at night, but you can smell it all day long. By the way, the world's largest acid lake is also located inside this crater. The Dead Sea has a high concentration of salt and minerals compared to other seas, even though it's technically a lake. Swimming is almost impossible, but people go there for the natural chemicals for the body. Floating on the surface is a great way to relax. This ancient body of water got its name because no macroscopic organisms can live there since it's 9.6 times saltier than oceans. Only a few bacteria and fungi can be found enjoying the salt. It's also Earth's lowest elevation on land at 1,400 feet below sea level. An underground crystal cave exists in Mexico, and it looks like some interstellar world. It's roughly 1,000 feet beneath the surface, with each spike measuring up to 35 feet in length and weighing up to 55 tons. These are some of the largest crystals in the world. Luscantar Beach is an endless strand of white sand dunes and azure water. But don't let the tropical vibes fool you. It's located in Scotland. That's why it mostly looks like this during May and June only. In December, the place gets only an average of 1 hour of sunshine per day, making it way more dramatic and monochrome. The Georgia Guidestones is a collection of giant stones in a star pattern. It has inscriptions in 8 languages, including Hindi, Chinese, and Swahili. It also has an astronomical calendar finished in 1980 and was built to last centuries. No one knows who built it or why. All the way over in sunny California is Sequoia National Park, home to the giant forest. It's been around for thousands of years. More than 8,000 of these colossal trees rule the land, including 10 of the largest living plants in the world. The General Sherman sequoia is estimated to be up to 2,700 years old and is recognized as the world's largest known living tree by volume. The famous stone heads of Easter Island have been around for hundreds of years. No one knows exactly why they were built. Some scientists think that local people believe the statues would make the soil more fertile. Soil analysis proved the heads did their job well. It's the best agricultural spot on the island. The chemical composition of the ancient hot springs in Pamukkale, Turkey, makes the water pouring over the edge look magical. They're not only good for cleansing your body, but the mind too. All the way in Saudi Arabia is a rock sliced perfectly in the middle with 2 pieces sitting parallel. What makes Al Nasla so unique is that it wasn't artificially done, but is a result of nature's work over the years. Now, this glacier may look like someone dropped tons of red paint in the middle of Antarctica, but it's actually the natural color. Blood falls is a result of extreme salted water mixed with iron oxide, giving out this eerie vibe in the middle of nowhere. In early May 2018, New England observed one of the scariest and most dangerous phenomena ever, a super long-track tornado. The frightening natural phenomenon started not far from Charleston, New Hampshire, and traveled toward the town of Webster in Merrimack County. It took the tornado 33 minutes to cover 36 miles and become the 3rd on the list of the longest track tornadoes in New England. In the Philippines, you can swim in some of the most crystal-clear waters and discover an underwater world below you in the province of Palawan. The municipality of Coron has white sandy beaches with many small boats riding through the many amazing sceneries. Tristan da Cunha is a small volcanic archipelago in the Atlantic, with the only neighboring cities of Buenos Aires, Argentina, and Cape Town, South Africa. It takes 7 days by ship to get to this unique place. If you want to escape from the rest of the world, staying with the 280 locals will make you feel like you're away from everything. During the first week of January 2018, unusually cold weather in the northeast United States froze the Atlantic Ocean in North Falmouth, Massachusetts. What's more, the ocean was frozen so thoroughly that people were walking on the waves. Now, that's obviously something you don't see every day. Red sand is what makes this beach unique and why tourists flock to Tianjin, China. A red-colored plant called a Sueda salsa dwells in the saltwater. The whole beach is covered in red, with only the top layer of the sea visible. If there ever was a thing that said, "I defy gravity" out loud, it's the stone of Damasco in Argentina. The huge 300-ton boulder stands precariously on the edge of a cliff and rocks a little bit from side to side in the wind. People even checked it by putting glass bottles under one of its edges. They exploded with another movement of the rock. Unfortunately today, you can't see this wonder of nature as it was a century ago. In 1912, the boulder suddenly dropped from its perch, which it had occupied for literally hundreds of years. The people of the nearby town of Tandil were so sad about this event that 95 years later, in 2007, they decided to restore the stone. They made a plastic replica of the rock and put it on the same spot and even in the same position. So, even today, coming by Tandil, you can see its famous balancing boulder. More of a symbol now, of course, because it's no longer rocking and only weighs 9 tons, but instantly recognizable nonetheless. Socotra is an alien-like island off the coast of Yemen in the Indian Ocean with one of the most unique trees ever seen. It's called the dragon tree, and it can only be found on this amazing island. In 2008, it was labeled as a World Heritage Site. If you ever see a tight burning column of air, don't panic, it's not the end of the world. The creepy combination of whirlwind sounds and scorching inferno means that you have crossed paths with a fire tornado, also known as fire twister or fire whirl. This dangerous phenomenon occurs mostly during wildfires. These fires create a big area of superhot air just above the ground. When this scorching air gets mixed with the cooler air higher up, it results in a whirlwind that churns up burning debris and flames. The most powerful firenadoes can stretch hundreds of feet into the air. The House of Mystery in Gold Hill, Oregon, amazes its visitors with gravity-defying effects. You can't stand straight there, always leaning to the side and having to hold on to something for balance. Balls roll upwards. There's also a broom that stands perfectly still wherever you put it, unlike virtually everything else in the shack. The local Native American tribes called this place the Forbidden Ground, even before the house was built there, and they avoid approaching it. The owners of the shack, though, decided to turn it into an attraction, and they succeeded. They created an atmosphere of mystery around the place, and spread the news about it in newspapers and later on the internet, and voila! A perfect anomaly is made. In fact, it's no more than a curiosity, a human-made optical illusion that tricks your eyes and other senses. Now, if you travel to the Philippines, Indonesia, or Papua New Guinea, you'll have a chance to see some of the most unusual and cheerful trees in the world. The trunk of the rainbow eucalyptus looks as if it had been painted orange, green, red, purple, yellow, brown, blue, hey, you name it. Some trees are so bright that they seem artificial. The rainbow eucalyptus regularly sheds strips of bark, which reveals a bright green layer underneath. A bit later, this green layer gradually changes its color. And since the shedding happens at a different time in different places on the trunk, the tree starts to look multicolored and very attractive. Yemen is home to the oldest skyscrapers in the world and the oldest metropolis. The ancient city of Shabam is considered to be the Manhattan of the desert, due to the collection of mud buildings popping out of the desert floor. It used to be a caravan stop during ancient times.